So, welcome. So, this is my first lecture on engineering graphics. Myself, Dr. P. Sadapma, Professor and Head, Department of Automobile Engineering, Industrial Institute of Technology, Coimbatore. I welcome you all. So, engineering graphics. So, some places it is also called as engineering drawing. Is the language of engineer to understand or communicating engineering ideas through the drawings. So, electronic engineer or electric engineer use the drawing for draw the circuits. To understand, if you take PCB design, how the PCB design will be. If you take any mechanical engineer, they draw the machine drawing. If you take civil or architecture, they can do the planning, they can draw the plan for the building. So it also elevation, something like that. So it is the representation of any ideas. It become a conceptual to data. It is universal language of engineers. It has some grammar. Don't afraid of that. It is the rules and conventions. So, as a language, rules and convention for engineering drawing may vary slightly from country to country. Like in Tamil Nadu, we are talking Tamil. If you go to some other North India, they are talking Hindi. So it is very, but understanding of things on conversation should be understandable. So in order to that, worldwide should be common. So based on that, India defined the standards from Bureau of Indian Standards, that is ISA standards, that is BAI 696 1972 for drawings. So based on that, 1983 English lettering and also same in 1983 size of drawing sheets and also scale of technical drawing, general principle of presentation, folding of drawing pins, 1985 title block, 1986 general principle of dimensions. These are created for to understand that this is my size of the title block. So font size will be something like this. Okay. So need of engineering graphics. So why we need engineering graphics? It has some accuracy and neatness, and it is based on the quality of the instrument used. Okay. I am a mechanical engineer or electrical engineer. Do I need to learn drawing? Yes, you have to learn drawing. So how to understand if any cut section is there in the machine or any drilling hole is there in the component. So based on that, based on the 2D drawing, you can understand there is a cut section, there is a drilling hole size will be varying 20 meter mm or 15 meter mm. So really you have to learn them. Mere degree code is not at all useful for anything. You have to understand completely the drawing concept and drawing principles. So even science graduate like MS and technical students completely has to know the drawings because engineering is application of science. Some of you fall in love with engineering like many other scientists who were originally science graduate may also pursue engineering careers in future. If you take Abdul Kalam, he's basically science graduates, then he went up the aerospace engineer. So why engineering drawing is necessary? First skill of engineer, plan the work. Second skill of engineer, to work according to the plan. Both requires drawing, maps and sketches. So need for engineering. Why these drawings need for engineering? So you have some way, there are different 4 or 5 way, but you have to get right designations, you have to select the right path that is optimized. So you need some dimensions, you need some knowledge, you need some function, you need some understanding of you are going to draw. So see this picture. So this picture Half portion will be the beautiful house, half portion will be the paper drawing. So this paper drawing will be the 2D XY. Okay, so it has some meaning. So how the height, how the foundation, how the window size, how much it has some sense. Either may be scaled down or scale up, but it has some meaning. How it will be, how it will be converted into original. So and also you need imaginations. So you need 100% imagination if you draw anything. So you cannot imagine how the flight will be today based on the bird that is in the flight. So and also you need some sense, understanding which one will be seen and seen. Something will be hidden, but you have to represent in the drawing. So there will need sense. So some concept it has to be real. So and also you have to know the analytical capability. Simply drawing and do some product. From that you have to know that after you use in the day-to-day life, how the product will be. Whether it will be withstand or the particular load, or it has the capability of withstand the environment. Based on the finite element analysis or computational methods, you can identify the strength, stability, or mechanical strength or physical strength of the any product. For that, you need analytical capability. So here some FEA analysis they have done it. So you need some common sense. Here, see here some railway workers are there, but instead of connecting the track here, so they connected here mistakenly. So need some common sense to do something like this. So and also understand how it will. You have to know that how it will be have to do. So and also how the thickness of the any material or any concrete mixing or kind of steel size, everything is meaningful. So even dam construction also you have to know that how the dam constructions, what is the level of depth of the water, how much water will be stored in the reservoir. So if you take today that is the Kalani Dam, it is a very big history for architecture. Today also people are many architects and civil engineers are amazed about that Kalani construction in the Karigal Swamps. It is the un unimaginable. Today also it is at the start. So and also some tunnel railway track, bridge over the railway track. So some statues, something like this. We need drawing height, this much height, how much foundation, what is the stability, how the truss members you need all calculations. So this drawing needs some instruments. Primary one will be the drawing paper. There are standards in the paper. There is A series and some aspect ratio. There is length and width ratios there. So based on that, A series A0, A1, A2, A3, A4. A0 will be 841 mm to 1118 mm. A1 will be 594 mm to 841 mm. A2 will be 420 mm to 594 mm. A3 will be 297 mm to 420 mm. A4 will be 210 mm to 297. Okay. You can see that A4 will print out. If you take print out, you can see that A4 size. So you can add these two A4 sheet, you get A2 sheets. So you have also different kind of pencil like this. This made of wood. Okay, it's a different kind of pencils. There HP pencil, H and 2H. You can use the HP pencil for drawing this, draw this fonts, and if you have H and HP, drawing the construction line of the drawings. Drawing of this pencil, you can use the sharpening the pencil. You can use conical tips or chisels. It is made of wood. So and also you have instrument like compass and divider. Even this is divider, this is a compass. So making a circle you need the compass. So divider, divide the line into some ratio 1:1 or 1:2 something like that. You can use this divider for marking pieces. You need good quality and also pencil needs to be fixed in here. So there are two kind of set square there. One is a 45 degree set square, another is a 36 degree set squares. Some scales are there. This it is made up of steel or hard plastics. It is normally it is written in the millimeter and centimeters. So diopter is a very large diopters. Now, in previous days, all the industries they are using this kind of diopters. There is a big table in front of the table. The designer will be standing. He used to draw the drawing for any component, even a month or 6 months, something like that. So nowadays, college students using mini diopter to the drawings. Okay, so these things will be replaced by the computer today. So we can use computer to draw the drawing, and you can get the 3D model also. You can use French curves to draw the different colors, something like this. So you need drawing clips to clamp the seat on the board. So board you have the clamp. You can fix the paper. You can clamp the paper. You can able to adjust the height as well as you can tilt the track. This is based on the human economics, the design. Using this scale T square and set square, you can draw the horizontal line, and also you can do vertical line. So vertical line you can draw this. So you can do some 40 degree angle using set square and 40 degree set square and as well as T square. So same way you can do the 30 degree and 20 degree based on this T square as well as some 36 degree set squares. So and also you can do 15 degree and 30 and 40 degree and 70 degree also. So you can have different kind of letterings. So it has some eligible or uniform and also some strokes. It has to follow the strokes. But carefully you have to practice. It has some width, height width ratio. You have some guidelines for each header line, then some other titles, something like that. You can use free and sketching also. Practice. See the letterings. So yeah, this is something I am using some plus. So this is this. So thank you very much for listening. My first lecture on introduction about HD graphics. Then next lecture we can see the next two. Thank you very much.